Hello everyone and welcome. So in this video we are going to see how we decide on which variable to split in decision tree and how this decision tree decides the splitting. So to begin, let's consider an example here. So here we have this data of student, whether they are going to pass or fail based on these two features, which is their attendance greater than 80, whether they have this attendance greater than 80 or not, and whether they attended the test 1 or not. So here we have total student of 20, out of which 12 passed and 8 have failed, and we want to build a decision tree to classify them into different subgroups, pass or fail. So here we can have the different decision tree, possible decision tree, right? So here if you consider, we can have this decision tree in the left and this decision tree the right. So we have two variables, right, the two features in our data set, and the number of possible decision tree is 2 here, right? So if you have n number of features, you can have n possible decision tree. So here if you see in the left, the splitting or first split is done on attended test, and here the right, the first split is done on attendance, right? So how do we decide on which variable should our first split occur, right? How do we decide this splitting criteria? So we can have n number of possible decision tree, right? How do we select this best decision tree for us? So we are going to talk about that. So let's move forward. So a decision tree uses multiple algorithms to decide to split a node into different subnodes. A decision tree splits the nodes on all the available variables and selects the one which results in more homogeneous nodes. So the goal of any learning algorithm in decision tree is to find the best split. Alright, so here there are two algorithms that we mostly use, which is Gini and entropy. So in this video we'll talk about how we decide our split based on Gini, and in our future video we'll talk about this entropy. So first of all, let's see what is Gini. So Gini says if we select two items from a population at random, then they must be of same class, and the probability of this is 1 if your sample is pure. Now what do we mean by this? Let's consider that you have this pure node here where you have only two circles here, right? So we have pure node, and if I tell you to select any two data points, then they are going to belong to same class, right? And probability of that is 1 as this node is pure. But in real world we don't have this pure nodes. So here we have this impure node where we have these red circles as well as blue circles. Now if I tell you to select 2 points at random and find the probability of them belonging to a particular class, then there is going to be different probabilities, right, for blue and red. So here your Gini is equals to p square plus q square. So p is probability of finding blue circles and q is probability of finding your red circles. Alright, so this is your Gini, and you calculate the Gini impurity to find out how impure your node is here. So it is given by 1 minus Gini. So now that we know what is Gini and how we calculate this Gini impurity, let's consider an example and work with it. So here, let's first of all split this data on attended test. So here we have this root node where we have all the data points. So here the total is 20, and after 20 pass equals to 12. So here red circles represent pass and the blue circle represent fail. Sorry, I said it otherwise. Here your blue circle represent pass and the red circle represent 8. So now you calculate the probability of pass and fail, and it is given by probability of pass equals to 12 by 20. It comes out to be 0.6, and probability of fail is 8 by 20, which comes out to be 0.4 here. Now you calculate the Gini. So Gini equals to 0.6 square, that is probability of pass plus probability of fail square. So it is 0.6 square plus 0.4 square, and it comes out to be 0.52. Now you can calculate the impurity at this node, right? And impurity is given by 1 minus Gini. So it is 1 minus 0.52, which comes out to be 0.48. So this is your impurity at the root node. Now we are going to split this data on attended test. So here we are going to split this in attended test equals to yes and no. So here let's consider this left subnode after splitting. So here after splitting, the total number of data point in your left subnode is 12, and pass is equals to 9, and fail, which is your red circles, is equals to 3. Now you again calculate the Gini here, and it comes out to be 9 by 12, which is equals to 0.75, and probability of fail, which comes out to be 0.25. Again you calculate the Gini for this left subnode, and it is 0.75 square plus 0.25 square, and which is equals to 0.625. So this is your Gini. Now again calculate this Gini impurity for this left subnode, and it is equals to 1 minus Gini, and here your impurity is 0.37. Again you calculate this for this right subnode as well. So in right subnode you have total of 8 data points. So here pass is equals to 3 and fail is 5. Now again you calculate the probability of pass and fail. So it comes out to be 0.38 and 0.62, and again you calculate this Gini for your right subnode, and it comes out to be 0.53. Then again you can calculate the impurity, and here the impurity for your right subnode is 0.47 here, right? Now that we have calculated the impurity of root node and impurity of this left subnode and right subnode, you have to calculate the weighted impurity for this split, and weighted impurity is your number of data points the left subnode divided by total number of data points into your impurity in left subnode plus number of data points in your right subnode, which is equals to 8 divided by total number of data points, which is 20, into your impurity in right subnode, and it comes out to be 0.41. So in our root node we had impurity of 0.48, right? So after this split our impurity is decreasing, or the other way to say this would be your homogeneity is increasing. So now we have seen this split on attended test. Similarly, you calculate this for split on attendance. So here we only have two variables, right? So if you have n number of variables, this is going to happen for your n number of variables, right? So here we have already calculated this impurity at the root node. Now let's split this on attendance greater than 80 and C. So here in the left subnode we have this total equals to 10 data points, and here pass equals to 6 and fail equals to 4. Again you calculate the probability of pass and fail, and it comes out to be 0.6 and 0.4. Then you calculate the Gini for this left subnode, and here your Gini is 0.52 and your impurity is 0.48 for this left subnode. Similarly, you calculate this for your right subnode after splitting. So here you have total equals to 10 data points and pass equals to 6, fail equals to 4 here. Then again you can calculate the probability of pass and fail. Then you calculate this Gini, which comes out to be 0.52 and your impurity is 0.48. Now again you take this weighted Gini impurity for this split on attendance greater than 80. So here your weighted impurity comes out to be 0.48. So here if you see at the root node we have this impurity of 0.48, and after the split we are also getting the impurity of 0.48. So there is no further decrease in this impurity when we split on attendance greater than 80 here, right? So here if we compare this two split, which is attended test and split on attendance greater than 80, then you have less impurity in this split on attended test, and your first split is going to be based on this attended test. And this is how you decide your best split and you grow your decision tree. So this is a repetitive process. Again you are going to calculate the split on different variables and select the one with the less impurity. I hope now you are clear about this, how we split the nodes in decision tree based on this Gini criteria. So thank you.